Pick a whole number, add 1, square the answer, multiply the answer by 4, subtract 3. Which of the following statements are true regardless of which starting number is chosen? Okay, and we're given a bunch of statements, and we have to choose which combination of these statements is correct. So what I'm thinking of doing here is to just go through these operations for a general value. Like I'll let n represent a number. I'll do all these operations and then see which of the options are true regardless of the value of n. So we start with a number n, add 1, square it, multiply the answer by 4, and subtract 3. So maybe I should expand this. Okay, so I end up with 4n squared plus 8n plus 1. Okay, the final answer is odd, so that's certainly true. Because these are both multiplied by 4 and 8, that's even. So the final answer is odd, so option 1 is correct. The final answer is 1 more than a multiple of 3. Possibly, but I don't think so. All right, this is 4n squared, it's 4n times n plus 2 plus 1. So if n is a multiple of 3, then it's true. If n plus 1 is a multiple of 3, then this is not a multiple of 3, and so answer 2 is false, so we can't confirm number 2. 3, the final answer is 1 more than a multiple of 8. No, I don't think so. You know, it's certainly 1 more than a multiple of 4. Right, if I let n be equal to 1, then this is 12, and so 3 is not correct. Okay, so let me do it like this. So let's look at option 2. Option 1 is correct for all values of n. Option 2, the final answer is 1 more than a multiple of 3. Okay, so well, if n is equal to 1, this is 12, so the answer is so yes. If I let n be equal to 2, so then I have 8 times 6. No, I have 8 times 4. Either way, that is not a multiple of 3. Okay, so 2 is incorrect. Option 3, the final answer is 1 more than a multiple of 8. So I've already confirmed that that's not correct. Again, n is equal to 1 shows that it's not correct. The final answer is not prime. That's incorrect. If n is equal to 1, then this will be 12 and 13 is prime. So 4 is also false. Well, and not true in general at least. The final answer is not 1 less than a multiple of 3. Well, let me first just make sure I went through this whole thing correctly, right? Pick a whole number, add 1, square it, multiply by 4, subtract 3. So n squared plus 2n plus 1, 4n squared plus 8n plus 4. Yeah, okay. The final answer is not 1 less than a multiple of 3. Well, how do we see? I mean, I'm sure now that based on the multiple choice options we're given, given that statement 1 has to be true and 2, 3, and 4 are all false, the answer has to be E, that options or statements 1 and 5 are correct. But how do we see that this number cannot be 1 less than a multiple of 3? Okay, well, 4n, n plus 2 plus 1. Let's mod this by 3. So 4 is 1 mod 3, n times n plus 2 plus 1 mod 3. This is n plus 1 squared mod 3. So 1 less than a multiple of 3 would mean that this is equal to 2 mod 3. If I set this equal to 2 mod 3, do I get a contradiction? I mean, it seems like very easy to make it 1 greater than a multiple of 3. And looking at this, it seems like we should be able to make it 1 less than a multiple of 3. Okay, well, the fact that we have n plus 1 squared, I don't really care about the plus 1, right? It just means we have some number squared where the number we choose it has to be 2 or greater rather than 1 or greater. So are there squares which are 1 less than a multiple of 3? I mean, let's write out the squares, right? 4, 9, 16, 25, 36, 49, 64, 81, 100. What if I think of my number as being 3k plus c, where c is 0, 1, or 2. So that gives us, k can be anything. C is 0, 1, or 2 to give us sort of all the options mod 3. This is equal to 9 k squared plus 6 kc plus c squared, which is equal to c squared mod 3. So right, if c is 0, then it's not 1, it's not 2 mod 3. If c is 1, that's not 2 mod 3. And if c is 2, yeah, so this is equal to only 0 or 1 mod 3. This can never be equal to 2 mod 3. And so, yeah, any time you square a number, you never get something which is 1 less than a multiple of 3. So yeah, so this is correct then, and the answer is E. Statements 1 and 5 are correct. I mean, by the process of elimination, we found this out quite quickly based on the options that are given. I'm just trying to understand. Is there a way from this that we can see it easily? I'm not going to think about it too much. I mean, this shows that if you square any number and look at it mod 3, it's always equal to 0 or 1. And yeah, we've shown that as long as we do everything mod 3, the entire sequence of operations, the final number here is equivalent to the square of something mod 3, which is always 0 or 1. Yeah, so anyway, that's the final answer. If I have more to say about this one, or if I find a mistake, I'll put it down in the description. Thanks for watching.